Geometry, Section 1-6, Part 1, Angle Classifications. These are probably words that you've heard before. We're starting simple, as you probably noticed here in geometry, to get ourselves a base foundation, a language that we can use and build upon. So the words are acute, right, obtuse, and straight, all referring to angles. Some textbooks would also include in this a zero angle, but that's pretty obvious, right? A zero angle is an angle that has a measure of 0. So we start with acute, and in each of these explanations here, x is the angle, okay? So if an angle is acute, if x is an acute angle, it's because that angle is something between 0 and 90 degrees. Now notice that we're not saying less than or equal to, right? It's if you read right to left, this says x is greater than 0, and then left to right, x is less than 90. Not or equal to, because if it's 0, it's not an acute angle. It actually is a 0 angle, but again, our book doesn't even cover that word. Whereas also x is less than 90 degrees, because if x is equal to 90 degrees, well, then that's called a right angle, and that takes us to our next word. A right angle, x is equal to 90 degrees. An obtuse angle is an angle between 90 and 180, not including 90 or 180 though. And then a straight angle is one that actually equals 180. A couple things. Number one, if you have trouble keeping acute and obtuse straight, I've heard through the years students tell me that they remember it because they think acute little angle. Okay, the smaller one is cute. I don't know if that works for you or if you need that kind of help, but that has worked for many students. And then the other thing is, so someone could say, well, why do you stop at 180? Why don't you have something? Why don't we have a name for something that's bigger than 180? For right now, and we will change this as we go through the book, but for right now, all you need to know is up through 180. There isn't a name for something bigger than that I'm aware of, and our angles are going to be 180 degrees or less until further notice. Okay, so acute, right, obtuse, and straight, and that's enough to go ahead and do a couple of examples. Let's talk about naming angles. When you name an angle, there's a few different ways that you could do it. What if I just told you, hey, look at this diagram here and look at angle G? Would there be any doubt what I'm talking about? Would you interpret that differently than someone else when I say angle G? I think everybody would know that I'm talking about the angle that is the space that is right in here, right? Angle G is something that we can measure with the protractor. By the way, that's what we're going to be doing in this section also, is measuring with the protractor. And that angle could be, without any confusion, be called angle G, okay? But now think about this, or consider this example here. What if I gave you this example, A, B, C, D, E, and now I said look at angle E. Do you have any idea what angle I'm talking about if I said look at angle E? It could be this angle, it could be this one, it could be this one, it could be this one. We don't know which angle we're talking about if we say angle E. In fact, angle E could refer to one of the straight angles. It could be this angle right here for all we know, okay? So basically what we need is a better way to name those angles, and that would be done by naming it with 3 letters, right? So angle AEB, for example. Angle CEB, for example. Angle CEB, let me use a different color, would be this angle right here, angle CEB. The middle letter should be at the vertex. You probably know that word vertex, where the angle would be measured from, again, if we were using a protractor. By the way, angle BEC would be the same angle as angle CEB, but again, notice that E is in the middle of those 3 letters, okay? Now, with that in mind, let's name this angle that they gave us a couple of different ways. We've already got out there that you could name it angle G. Just the same, you could name it with 3 letters, and that would be angle CGA. And you could also name it angle AGC. Now, it escapes me if we've mentioned yet the angle symbol in a previous lesson. I'm not sure I have. So this symbol right here is the angle symbol. You should use that just the same way you use the segment symbol for, with 2 letters and the segment symbol, the ray symbol, and just like that, the angle symbol is required. It doesn't go over the top, but it comes first, and you should use that when referencing an angle. Here's angle G, here's angle CGA. It's the same angle, it's just naming it with 3 letters instead of 1. and angle AGC, just flipping C and A to AC, A and C, that's AGC, G being in the middle, is a third way to name the angle. Okay, and I already explained to you why we would need that. Here's the fourth way, and again, I'd like you to consider a kind of an alternate drawing here. The fourth way is going to be angle 3. Okay, it's kind of out of context when you just look at this simple example. But again, if I give you something a little bit more, it was a little bit clunky when I drew this for you, and I did A, B, C, D. An easier way to do this is like to go 1, 2, 3, 4. Okay, that was a lot faster than putting a dot and naming it with a capital letter, putting another dot, and then so much the more when we get into diagrams that look like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Okay, so back to the problem: 4 different ways that we can name that angle. This says find the measure of each angle, classify each as acute, right, obtuse, or straight. Give you a minute to kind of investigate there. I think clearly angle 1 is obtuse. I think angle 2 is a little bit harder to see, but if you look at it closely, I think you would agree that it's acute. It's less than 90 degrees. 90 degrees would cause perpendicular, and I think that would come out here just a little bit more. So I'm going to say that this is acute, although that was a little bit closer of a call than the first one. Together, would this angle be a straight angle? I think not. I think that's a little bit of a break that causes that angle that I just marked to be more than 180 degrees. This angle here would be obtuse, but they didn't number that one anyway. So I think what they're going for here is angle 1 is obtuse, angle 2 is acute. I hope you agree. They did even measure with a protractor here. And there's your answer. They agree. They agree with what we said. Okay, and then finally, the measure of angle 1 is equal to 42 degrees. I'll mark that here. That's this space right here, measurable. I keep saying measurable with a protractor, although when they tell us it's 42, don't go using your protractor. If they tell us it's 42, no matter if it actually is with a protractor, you're going to trust that it's 42. And they also say that the measure of angle ABC is 88. Notice the difference in notation. Angle 1 is 42. Angle ABC, using 3 letters because we're talking about this large angle here, is 88 degrees. That's like saying this whole thing, 88 degrees. And they want us to find the measure of angle 2. Now, wouldn't that just be a simple subtraction? Here's the thing, though. Would you agree with this? The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC. Wouldn't everybody agree with that? Now, I bring that up because in the previous lesson, I talked about something called the segment addition postulate. When you have one segment and you add it to another segment that is along the same line segment, if you will, sharing an endpoint, then they add up to the longer segment, right? Basically adding the 2 small ones together to add up to be the large one. It's the same thing here with angles. Angle 1 and angle 2 together, they form angle ABC. So the sum of angle 1 and angle 2 is equal to the measure of angle ABC. This is going to be known as the angle addition postulate. And again, just like I told you with the segment addition postulate, the name of it is not important right now, but one day it will be. So I want to introduce it to you now, and then I'll point back at this lesson and reference the angle addition postulate. Bottom line is you can add those 2 angles together to add up to the big one. Basically, 42 plus the measure of angle 2, which we don't know yet, is equal to 88. And these are in degrees. And if you would then just subtract 42 from both sides, the measure of angle 2 is going to be 46 degrees. Okay? It would be hard for me to do the last part of this lesson with how to measure with a protractor and how to draw an angle with a protractor. So I'm going to pick 2 videos off of YouTube done by someone else, and I'll include them in my post on Google Classroom. If you already know how to use your protractor, then you may not need to watch those, but I'll leave that up to you. The last thing I want to say simply is that there is such a thing then as congruent angles, and angles can be congruent. If angles are told to us to be congruent, it is because we can assume then that their measures are equal, because that's what congruent means. Congruent angles have equal measure, and I could write something like the measure of angle XYZ is equal to the measure of angle TUV. And that would be equal measures, or we can simply say angle XYZ is congruent to angle TUV. That's all for now. Thank you.